Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. At the start of a week, a coal mine has a high-capacity storage bin that is half full. During the week, 20 loads of coal are added to the storage bin. Each load of coal has a volume that is normally distributed with mean 1.50 cubic yards and standard deviation of 0.25 cubic yards. During the same week, coal is removed from the storage bin and loaded into 4 railroad cars. The amount of coal loaded into each railroad car is normally distributed with mean 7.25 cubic yards and standard deviation 0.50 cubic yards. The amounts added to the storage bin or removed from the storage bin are mutually independent. Calculate the probability that the storage bin contains more coal at the end of the week than it had at the beginning of the week. And here's the solution. Since each load of coal has a mean of 1.5 and standard deviation of 0.25, 20 loads have a mean of 20 times 1.5, which is 30, and a standard deviation of square root of 20 times 0.25. The total amount removed is normal with mean 4 times 7.25, which is 29, and standard deviation square root of 4 times 0.5, which is 1. The difference, let's call it d, is a random variable which is normal with mean 30 minus 29, and that's 1, and standard deviation of a square root of 20 times 0.25 squared plus 1 squared, which is the square root of 2.25 or 1.5. They don't have any covariance because they're independent, so that's why we only take the square root of the sum of the variances to get the standard deviation. The probability we're looking for is probability that d is more than 0, which is the probability of d minus 1 over 1.5 being greater than 0 minus 1 over 1.5. But d minus 1 over 1.5 is standard normal. Normal random variable with mean 0 and standard deviation of 1. And we write z for that, so that's probability that a standard normal random variable z is greater than negative 1 over 1.5. which is the probability that z is more than negative 2/3. And that's the same as the probability that z is less than positive 2/3. So z more than negative 2/3 has the same probability as z being less than positive 2/3. That's approximately 0.67. So we want the probability that z is less than 0.67, and from the table we look it up as 0.7486. And that's answer D. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.